Hello friends, in this video we are going to discuss the construction and torque equation of electrodynamometer type instruments. Okay, so here this figure indicates the construction of a EDM, that is the electrodynamometer type instruments. Okay, so in the construction it consists of two fixed coils. So here it is the one fixed coil and here it is the second fixed coil we are having. Fixed coils are also known as a current coil. This CC stands for the current coil and it is having one moving coil. The moving coil is known as the potential coil, or it is also known as the pressure coil, okay, or the voltage coil. Okay, so this is the these two are the current coils and this one is the pressure coil or the potential coil or the voltage coil. Okay, next, on the fixed coil we have wound a winding. Okay, so we are having the winding which we have wound on the fixed coils. Okay, also on the moving coil also we are having a winding wound. Okay, so now depending on whether the electrodynamometer instrument we are using it as a voltmeter or ammeter or wattmeter. Okay, here the connections of the fixed coils and the moving coils, it depends. Okay, that we are going to discuss in the coming videos. Okay, so here we are having the meter terminal. This is the one meter terminal, this is the second meter terminal, right? Next, here it is the instrument spindle we are having. Next, the spring control is used, so spring is connected here, and here we are having the pointer and the scale. Okay, this is the scale and here it is the pointer we are having. Okay, pointer. And sorry, getting the point, we are having the two current coils, one potential coil. Okay, scale arrangement, pointer, spring control. Okay, now in the operation this meter works on the principle of DC motor, just like a DC motor. So what is the principle of DC motor, working of DC motor? So it is a when a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. Okay, so now here we are having, here it is the magnet, right? This is the iron material made up of the structure which is made up of the magnetic material. Okay, and onto this we have wound a coil. So this arrangement it forms the electromagnet. Okay, this arrangement forms the electromagnet. So we will be having the magnetic lines of force which will be starting from north to south, north to south. Okay, and into that we are having a moving coil. Okay, and also the moving coil, on the moving coil also we are having the winding placed. Okay, so now when the current carrying conductor is nothing but your moving coil. Okay, is placed in the magnetic field, it experiences a force. Okay, so I'm writing it as when it works on the principle that states when a current carrying conductor placed in a magnetic field, placed in magnetic field, it experiences a force. It experiences force. Okay, and according to that, that force is nothing but your torque. Okay, and that torque is nothing but the deflecting torque. Okay, which is equal to I1 into I2 into cos phi into dm by d theta. Okay, where Td is the deflecting torque, right? What about the I1? I1 is the fixed coil current, or it is a current coil current. I1 fixed coil current. What is I2? I2 is moving coil current, right? What is the phi? Phi is the angle between I1 and I2. Okay, and what is the M? M is the mutual inductance between the coils. And what is theta? Theta is the deflection of pointer. Okay. So simple operation we are having, when a current carrying conductor is placed in a magnetic field, it experiences a force. Okay. So this moving coil will experience a force. Due to that, this spindle and in turn this pointer will rotate. Okay. So more the current flowing through the moving coil, more will be the deflection of the pointer, because that more torque will be produced. As we know, the torque is nothing but the interaction of the two fluxes. Okay. So now this is the expression for deflecting torque, TD. As the spring control is used up, so what is the controlling torque expression? It is a K into theta. Okay, so spring control is used up. Therefore, TC is equal to K into theta. TC is the controlling torque, K is the spring constant, and theta is the deflection. Okay, as we know, at equilibrium, right? At equilibrium, TC is equal to TD or TD is equal to TC. Okay, so it is K into theta is equal to, we are having I1 I2 cos phi dm by d theta. Okay, so therefore we can write theta is equal to I1 I2 cos phi dm by d theta divided by this constant q. Okay, so this is the expression for the deflection theta. Okay, in EDM type instruments. Also, in this type of instruments, the air friction damping is used. Okay, so this is about the electrodynamometer type instruments. Right, in the coming videos we are going to discuss how these instruments can be used as a voltmeter, ammeter, and most popularly as a wattmeter. Thank you.